Okay, this is number 10 in section 4.5 of Algebra and Trigonometry, Larson-Hostetler, 6th edition. So this is a slight variant on number 8 here. All we're doing again is we're going to rewrite the equation into standard form for a circle. What we're going to do again here is we're going to group the x terms and the y terms together and move the constant to the other side. So again, I'm going to group the x terms and the y terms together. Okay, so those are the x terms. I'm going to leave a space. And I'm going to group the y terms together. And I'm going to move the constant over to the other side, -17. Okay, there's just one little extra nuance in this problem compared to number 8. I don't like a leading coefficient of 9. I need a leading coefficient of 1 to do the completing the square a little more simply. So what I'm going to do is I'm going to factor out a 9 out of both the x terms and the y terms here. I'm going to factor out 9. Again, now my leading coefficient is a 1. That is what I'm looking for. Okay, now we're going to do similar to what we did for number 8. We're going to try to turn this into a perfect trinomial. We're going to try to complete the square here. Again, what I want to do is I want to divide this number by 2 and then square it. 6 divided by 2 is 3. 3 squared is 9. Okay, this time it's a little different. Okay, right here I'm adding plus 9. But if I'm not just adding plus 9 to both sides, I'm adding 9 times 9 to both sides. 9 times 9 would be plus 81. Again, let me explain that again. To complete the square, I divided by 2 and squared it to get 9. But I'm not just adding 9 on this side. If I distribute here, it would be 9 times 9. It would be 81. I'm actually adding 81 to this side. Therefore, I must add 81 to the other side. Okay, same idea here. -4 divided by 2 is -2. Square is +4. But again, I'm not adding just 4 to this, to both sides. I'm going to be adding 4 times 9. 4 times 9 is 36. I'm going to be adding 36 to both sides. Okay, I'm going to factor it and then simplify the right side here. So I'll have 9x plus 3 squared plus 9y minus 2 squared equals, let's see, -17 plus 81 is 64 plus 36 is 100. Okay, we're not done yet. So if we look at the standard form of an equation again, it would be x minus k squared plus y minus h squared equals r squared. So the problem we have right now is we have these 9s. So that doesn't look right. So what can we do? How about we just divide both sides by 9? So we'll divide every single term we have here by 9. Okay, so if I do the work, and put it down here, I would have x plus 3 squared, because the 9s would cancel out, plus y minus 2 squared equals 100 divided by 9. Okay, so now, hey, look at that. It looks a lot like the standard form now. Okay, but let's just simplify it one more time so we can have this. Let's put 100 over 9 into a squared form, which would just be, let's rewrite everything really quick here. 100 over 9. So that would just be 10 squared over 3 squared which would be 10 over 3 squared. Okay, we got all the information we need then. So right here, we know the k, we know the h, and we know the r. So our center, it's an x plus 3. Again, that's the same thing as saying x minus negative 3. So it would be negative 3, positive 2. And my radius would be 10 over 3. Okay, that completes our discussion on standard form equations for a circle and rewriting equations into a standard form equation of a circle. The next topics will include ellipses, parabolas, and hyperbolas.